Okay. So we're a few minutes behind, but only missed a couple things. All right, so then, so we take that -2, multiply it 4 times. But here, the exponent happens before the subtraction, okay? So we're going to take and we're going to do, so there's really, because we do the exponent first, there's really like an applied parentheses. Okay, we're going to do that thing first, and then we're going to take the minus. Because minus is, honestly, it's like going to be the last thing you do, right? The subtraction and addition. So we're going to take that minus, we're going to put it out there, and we're going to focus on the 2 to the 4th. So we're going to multiply 2 times 2 times 2 times 2, and then we'll do the minus. So what's 2 times 2 times 2 times 2? Well, these first two will give us 4, so we have 4 times 2 times 2. These two will give us 8, so 8 times 2, and then I have 16. And I'm really drilling this home because notice I'm doing everything left to right, right? I mean, I could have done it. We know that, by now you know that multiplication is commutative, so you could switch things all around. But, you know, we're just doing focusing on PEMDAS right now. All right, so then here, these two -2's, when you take a negative and you multiply a negative, what do you get? Positive. How about a negative times a positive? It's a negative. And then, you know, from elementary school, a negative times a positive. I mean, a positive times a positive is positive. Okay. All right, so then -2 times -2 is a positive 4, and I have times -2 times -2. So negative 4 times -2 is negative, right? -8. And then times -2. And what do I get? Positive 16. Because if you have an even number of negatives, they're all going to cancel each other out, right? Okay. All right. So these are two different things. So the parentheses must be used to include the negative in the power. Otherwise, the negative can't be included with the repeated multiplication. All right, so just so I can make sure, and here's where, oh, Joseph, did you want to say anything to the class? We have an embedded tutor here who's going to help me out. Do you want to say anything? Or? So what are your hours there?
Yeah, I'm there Mondays, 12 to 7, and today after 3 o'clock.
Oh, really? Oh, that's great.
Usually I start at Monday after class.
Okay, so you're here before and after class. Okay. Great, thank you. James. I was drawing a blank on the name. Yeah, James was here on Thursday. He's also there. Okay. All right, thank you. All right, so going to have them try these on their own, and then you and I will just raise your hand when you're done with the 4 of them, or if you have questions, and then we'll go from there. Chair. It's a mess.
Plus it also shows on the real so you have them minus outside. So minus potential four, and then you can stuff inside 16 and then you have the negative 5. Does that make sense to you?
Okay, I think enough of you are done. Is anybody like super stuck and they want one-on-one help? Yeah? Okay. All right, so I think everybody pretty much got these, so we'll just run through these real quick. So we have here, I have a negative 5 times negative 5 is going to be 25. Is a positive, okay? All right, and then here I have a negative 2 times a negative 2 times a negative 2. I'm multiplying that negative 2 3 times, right? So the negative 2 times the negative 2 is 4 times the negative 2, and I'll get a negative 8. Okay. Here, this one, pretty much everybody got this one. This is just 36. 36 times 6 is 36. You probably learned that in elementary school. All right. This one, we're going to focus, like that's kind of like the parentheses, or on the exponent part first. The minus is done later. So I even saw some of you doing it like this. This is perfect. Because then I know that you understand what you're doing. All right, so then you have the minus and then the 16 here. So it's negative 16. Okay, does everybody understand that? Okay, I like to make sure we understand that before we get into the more complicated ones. So some of you moved on. And this is basically saying PEMDAS, which we already went over, so I'm not going to go over it again. All right, so first thing we do, we look for parentheses, right? So my parentheses are right here. So I'm going to do that first. First step. So I have 5 times, what's 8 minus 10? Negative 2. Okay, so we all know how to add and subtract positive and negative numbers, maybe? All right, so then I have plus 2 to the third divided by 4. What do I do next? Exponent. So the exponent's right here. So I'm going to have 5 times a negative 2 plus 2 to the third is 8. 2 times 2 times 2 is 8. 8 divided by 4. All right. Then I'm going to do my multiplication, division, division, multiplication, whichever way it comes, right? So, of course, first we have multiplication. So 5 times negative 2 is a negative 10. Next multiplication division we come to is the 8 divided by the 4. Okay? So we get 2. Negative 10 plus 2 is negative 8. Okay? So who got negative 8 if you went on ahead? Okay, very good. Are there any questions on that? Okay. Okay, so this one, I like to say that, like, they put, so first we do parentheses, right? And you see there's a parentheses here, but it's really just one number. It's negative 1. It's just the number negative 1. So they're just trying to help you understand that as compared to it being minus 1, it's a negative 1. Because you see there's a multiplication symbol right here. Okay? So we really don't do anything with it. We just remember that that's one blob, negative 1. Okay? So let's look at the next parentheses is here. So we're going to do that first. So what's 3 times negative 1? Negative 3. So we have negative 3 to the third. Okay, now we're going to do this parentheses. Negative 3 minus 4 is negative 7. Very good. So we have negative 7 squared. Then we do exponents, right? We did the P, now we're doing the E. So we do the exponents. So let me just say, okay, negative 3 cubed. Let's just do that on the side real quick so we don't get confused. We have a negative 3 times a negative 3 times a negative 3. Right? Negative 3 times negative 3 is positive 9. Times negative 3, what do we get? Negative 27. Very good. So this is a minus, and then this is a negative 27. Okay? That trips people up a lot of times. Because you still have that minus, we're just doing this exponent part right here. We keep the minus outside. All right, and then I have plus negative 7. This is just negative 7 times negative 7. What's that? Positive 49. Okay? Okay, so what is a negative? So if I'm walking on a number line and I go backwards, and then I go forwards again, a negative times a negative is a positive because I'm going in the positive direction. Okay, so this is just going to be 27 plus 49. All right, so what do I get? 76?
Not in the eight.
I think it's 76. So it's 76. Can you see that? Can you see it? Oh, come on. You can get it click there. Okay. Okay, next page. You guys seem like you're doing pretty good. You want to try these ones on your own? Yeah, okay, so how about if you do those on your own? And just raise your hand when you're done with those two. Just those two up top. Okay? Just raise your hand when you're done. I'm going to make you work too.
You look at all the exponents on the top. See, like I kind of, like the other people just doing the top with them for this, but I do all the exponents on the top and writing down the exponents on the top. That's what I'm seeing. Like, the exponent parts to do it.
Okay, so let's do it together. All right, so I did this first one, negative 16. I think everybody pretty much got that one. So here, we're going to do the negative 3 cubed. So I'm going to do the negative 3 cubed first. What do I get? Negative 27, right? Plus the 7 divided by 3 cubed is 27 minus negative 3 squared. What's negative 3 squared? 9. All right, so then on the top, I have a minus and negative, so I have 2 plus 27 plus 7 over 27 minus 9. All right, so on the top, I get 36, right? On the bottom, I have 18. Does everybody understand that now? Okay, so we get 2. Okay, so there's going to be arithmetic mistakes. You know, the more you practice, the more those arithmetic mistakes will go away. All right. So now on these ones, basically, you know, this is just 0.7 times 0.7. All right, you plug that in the calculator, what do you get? 0.49. Okay, this one is just going to be 1.3 times 1.3. What do you get here? 1.69. All right, I don't know this one. 0.52 times 0.52. What do you get? I don't know that one off the top. 0.2702? 04? 04. Okay, now, notice that it did not say to round, so we have to write all the digits. If you're on a test and there's like a whole ton of digits and it doesn't say to round, raise your hand and ask me, and like, Miss Marmol, really, can I just round this, right? So, just let me know, because probably a mistake. Okay, so this one is 0.2 times 0.2 times 0.2. What do I get? 0.008. Very good. Thank you. All right, and here I have 0.01 times 0.01. Please, everybody, plug that in your calculator. I want to hear if you get different answers. What did you get? Did anybody get it yet? Go ahead. Yes. So you got 0.0001. Is that what everybody got? No one got anything different? Yes. What did you get? Do you mind if I share them? Okay. All right. So she has a TI-84 Plus. This is not a calculator that we use in this for the test, but she's free to use it here. But notice, because you might get it, you might be using a calculator like this, and you might be like, huh? What is that? 1e to the negative 4. Okay, that is scientific notation. We'll get into that shortly. So what that is 1 times 10 to the negative 4. Okay, so if you took 10 to the negative 4 power, you'd get 0.0001. So it's the right answer, it's just in a different format. Thank you. That was perfect. All right. Okay, so how about 0.05? 0.05, 0.05, 0.05. We got 0.000125. Okay, cool. Because 5 cubed is 125, and then we have to have 2, 4, 6 decimals, so we move it over 1, 2, 3, 4, 5, 6, if you want to know. But really, you can just use your calculator. You don't have to know that. All right. So order of operations. I'll just whip through these. I think you guys all got the hang of it now. So first thing you do is the power, right? So we're going to do that power. We're going to get 3.2 plus 1.94 minus 0.25. 0.5 times 0.5 is 0.25, okay? Everybody convinced? All right. So plug that in to your calculator. What do you get? 4.89. All right. Good? Okay, so now here I'm going to take this 1.2 times 1.2, and I'm going to get 1.44. Then I'm going to put 22.1 plus 1.44 times 0.2. What is the next operation that I need to do? Multiplication. So I'm going to multiply. I'm going to do this part next. So we get 22.1 plus, did you get 0.288? Is that right? Okay. So then I get 22.388 as the answer. Are there any questions? Because I see several faces that look like they have questions, but I have a hard time knowing what I'm not explaining well. Everybody. Sometimes you guys don't know what to ask, so we'll just keep on going. Okay, so we have here, we'll do the exponent first. We have 2.1 squared. That's going to be a 4.41 plus 3 times, well, really, I should have done the parentheses first, right? So I'll just do that now. 4.38. Because 8.6 minus 4.22 is 4.38. So just filling that in. Do that first. Okay? All right. So now I'm going to do the multiplication here next, okay? So I have 4.41 plus 3 times 3 times 4.38, 13.14. And then I'm going to add that to 4.41. Can you see that? Okay. So I get 17.55. Okay? That's my answer. Okay, what operation in this last problem, I want you all to tell me what is the first operation I'm going to do here? Exponent. Good. Okay, so we're going to do the exponent first. So I'm going to just put in my calculator 1.3 times 1.3. I'm going to get 1.69. I'm just going to copy everything else down. Okay, what's my next operation, everybody? Division. All right, so I'm going to do this. Then I have 9 plus that. 9.24 divided by 0.02. Excuse me. 9.24 divided by 0.2 is 46.2. Is that what you got? Okay. And so I have 9 plus 46.2. We get 55.2 minus 1.69. So I get 53.51. Okay? Okay, you good? Okay. All right. Check. I've got lots of time left. All right, so let's go on into number 32. Okay, my goal is that we get through. So what I really, really want to do before the test, like, I'd like to get number 32 in today, and then problem solving 2 on Thursday, so that we have all day the day before we meet for the test to do the practice test together. Okay? So it'll be a group activity. All right, so let's move on into number 32. Okay, so who here speaks Spanish? Anybody speak Spanish? How do you say 100? 100. C-I-E-N. 100. Does anybody speak French? Okay, so French is cent, C-E-N-T. So it's exactly cent. Okay, so cent cien, cent, right? They sound very similar. That means 100. So cent means 100. Okay? Percent means out of 100, or divide by 100. So per, when I say the word per, that means divide. Okay? So if you think about, yes. Yes, thank you. Thank you. Appreciate your help there. Okay. So cent means 100, per means divide. If I say I'm going 50 miles per hour, that means I'm dividing by hours. Okay? Per 1 hour, divided by 1 hour, right? But I could say I'm going 50 miles per 2 hours, right? That would mean I'm dividing it by 2. I'm really going 25 miles an hour. Okay. All right, so basically whenever you have that percent sign, it means per 100. So if you have something like this, it means that you have 30 divided by 100. Okay? So just a little mnemonic trick, not that it means this or anything, but you could kind of think of this percent sign, and you could turn these into the 2 zeros, and you could turn this guy into the 1. So I don't know, just something to maybe help you remember. So that divides by 100. Okay. So to convert the percent to a decimal, you have to get rid of the percent sign. So we throw away the percent sign, and we move the decimal point to the left or right. Does anybody know? The left. Good. And honestly, if you have 20%, it's 20 divided by 100. You could just grab your calculator and go 20 divided by 100, and you get, and multiply. 20 divided by 100, and you get 0.2. Okay? Right. So that's that. So basically, we're going to move them to the left. So I'll do the first one, and then you guys just quickly at your desk do you don't have to raise your hand or anything. But we'll move this over to the left too, and I'll get 0.12. I need to see it written clean like this. I like to see you moving it, but I don't want to see that as part of the answer. Okay, so the first one, we had to have it with a 0. So we move that over to the left 2, we get 0.07. Here, we just move it over 2, we get 0.542. Here, we move it over, and we have to pad it again. Even though there's already a 0, we have to put an extra 0, so we get 0.009. And here, we just get 2.5. I can drop off that extra 0 on the end. It could be there or not be there, it doesn't matter. Are there any questions on that? Pretty much just moving that decimal over, sometimes you have to pad it. Okay. Okay, so now we're going to go the other way around. So now we're going to have the decimal, we're going to convert it to a percent. Okay, so in other words, we're going to move the decimal point. Which way do we move it now? To the right. Okay, and we have to add the percent sign. So if we have 0.5 and we want to convert that to a percent, we take that 0.5, we can multiply it by 100. So 0.5, don't be afraid to get your calculator out. 0.5 times 100, and we'll get 50. Okay, so 0.5 is basically like 50 cents, which is half, so it's 50%. Okay, and don't forget to add your percent sign. Okay, So what do I get here? Move this to the right 2. I have to pad it with a 0. We get 20%. What do I get here? 7%. Move it to the right 2. And so the decimal is after the 7. All right. And then here, I move it to the right 2. The decimal ends up after the 5. So I have 45%. I take this one, I move it to the right 2. I get 212%. Okay. So I know it's kind of weird to have a percentage that's bigger than 100%, but we will talk a little bit about that in a future section. Okay, why would you have more than 100%? Okay. So when you're finding a percent of, usually means to multiply. All right. So, for example, if I say it's half of 22. If I say, take half of 22, what would you get? What would you tell me? 11. Half of 22 is 11. Half of 20 is 10, right? You just divide it in half. So basically 1/2 times 22. So of means multiply. What does per mean? Divide. And what does cent mean? 100. Okay, so per is divide, of is multiply, and cent is 100. Okay, good. So now, that one was kind of easy, right? Half of 22. But what if we had 74% of 65? Now that's a little bit harder, right? But it's going to be multiplied. But let's go through a problem. All right, so if you want to find 4% of 23. So the first thing you want to do is you want to convert that 4% to a decimal. What do I get? 0.04. You just move that decimal over to the left too, right? Or I could take, if I get confused, I can just say, well, as Marvel said, percent means divide by 100. 4 divided by 100 is 0.04. I have a calculator on the test. I can just use it. Okay? No problem. All right, so then when you use a calculator, you put 0.04 in here. Okay? And then you're going to, so 4% of multiplied by 23. So you put that times 23 is 0.92. So the answer is 0.92. So I think I'm going to have you guys try these 4. And again, raise your hand when you're done, and Joseph and I can come and double check. Okay, so what did you get for the first one? You got 0.6 times 55, right? So did you get 33? Okay, good. And then you got 0.21 times 40, and then you got 8.4, and then you got 0.06 times 32, and what'd you get there? 1.92, okay? 0.95 times 15, and we got 14.25, all right? Okay, so let's talk a little bit about the properties of equality. So we're dealing with real numbers, right? And we have certain properties associated with those real numbers. Okay, so the commutative property means that the numbers change places. Okay, and I don't know if this is helping students, but I tell them that I drive down here from Melbourne every day to teach because I love this school. It's a great school. Very fortunate, grateful to work here. So that is me commuting, right? I'm commuting. And aren't I changing my location from Melbourne to Vero every day? Okay, that's commuting, okay? So you're changing the location. All right, so if I have 6 apples and I have 9 apples, it doesn't matter if I say 6 and 9 or 9 and 6. I have the same number of apples. It doesn't matter which order I add them in. Okay, that's the commutative property. Associative. If you think about, you know, the number 9 and the number 3, they're friends. They associate with each other, right? They're associating with each other. Well, then all of a sudden the 3 makes another friend with the 5. Okay, so now he's associating with the 5. But it really doesn't matter what order these numbers associate, because we're going to end up with 9 apples and 3 apples and 5 apples, no matter which way you dice it, right? No matter who's friends with who, there's still the same number of apples. All right, so that is called the associative property. So just think you associate, okay? But there are going to be some tricky problems, but we'll go over that. Okay, identity. If you have any number and you add 0 to it, what do you get back? Same number that you started with, right? So that is an identity. That means that, you know, its identity is that number. So that 0 is letting it keep its identity. All right, so just trying to give you some mnemonics to remember these things. Okay, so here what we do is we fill in the blanks. So right here we've got a 2, here we've got a 7, and here we have another 7. So I want you to just think for a minute, without calling out the answer, just think for a minute, what would you put in these blanks? So this first one has parentheses, right? The parentheses are moving. They're here, and now they're over here. The 6 and 2 are friends, and then the 8 and 6 are friends. So this is the associative property of addition. Yes? Okay, because I have 8 apples, 6 apples, and 2 apples. That's a really good question, by the way. Thank you. If they're going to be equal, it has to have another 2 apples. Okay? Does that make sense? Yeah. Okay. So, I mean, the point is that we're proving that it's the associative property, but you know that if you have an 8, 6, and a 2 on the left side and they're equal, it has to have an 8, 6, and a 2 on the right side. Okay? So here, if I have my answer 7, and I added 0 to the number that's still in the blank, it would have to be a 7. That's the only number that I could add 7 to, that I could add to 0 to get 7. All right, and then here I have a 7 and a 3 on the left side. I mean, that equation is a really, like, contractually binding sort of thing. We cannot break that equality. Those two sides always, always, always have to be equal. So anything we do to one side, we have to do the other side. All right? All right, so So what is the second one, you think? Identity. And the last one? Commutative, because they're changing your location. Okay. Okay, so now here, I want you to think for a minute. Just because there's parentheses doesn't mean it's associative property. All right, so we've got a blob added to a 5, and we have a 5 added to a blob. Didn't the blob move? Didn't the blob move from here, from the left side to the right side? So this is the commutative property, okay? Tricky. It's technically the commutative property of addition, but that's what the header says, so I'm just going to put commutative. All right. So now I have 2x and a 5 and a 2x and a 5, same order, right? But the parentheses move from here, the 2 and the x, to the x and the 5. So what's this? Associative. Okay. Lastly, this is the identity because I'm adding 0, right? So identity. Okay. Properties of multiplication. Well, guess what? Multiplication is really just addition under the hood, right? So if we multiply something, we're just adding it a bunch of times. It really has a lot of the same properties as addition. So it has the commutative properties, so they can change spots. Okay, if I have a 3 by 2, don't I have the same number of boxes as if I have a 3 rows and 2 columns? It's the same number of boxes. Doesn't matter which way I multiply it. Okay, so you can multiply in either order. Okay, so that's the commutative property. Well, it's actually kind of up here. All right, associative property, same thing. If I multiply 9 times 3 first, and then multiply the 5, or if I multiply the 3 times the 5 and then the 9, it doesn't matter, I'll get the same answer. That's the associative property. Now, the identity is a little bit different for multiplication, right? What's the identity? 1. Okay, so if I multiply by 1, I get back the same number. Okay, so 0 then becomes kind of like another thing that multiplication has that addition doesn't have that extra 1. So we just call it the 0 property. If I multiply something by 0, what do I get? 0. So if you times 0 times, so if you have 8 apples, 0 times, you don't have any apples, right? So that's the 0 property of multiplication. All right. So here's our fill in the blanks again. All right. So I want you guys to think about what would I put in this blank right here to make it equal to that other side? 9. Okay. So if I have a 5 and a 4 and a 9 on the left side, then I'm going to need to have it on the right side. So what property is that? Associative, because they're in the same order. Okay, if they change the order of anything, then you suspect commutative. But both sides have 5, 4, 9 in that order. So that would be the associative property, because only the parentheses are moving. Okay, what times 11 is equal to 0? 0. So what property is that? The 0 property. I don't know why I wrote it out this time, but not the others. 0 property of multiplication. All right. So if I know that I have 13 times 7 on the right, and I have a 13 here, what must be in the blank? 7. And what property is that? Commutative, because they changed locations. Property of multiplication. 22 times 1, 22. And what property is that? Identity. Very good. Okay, check. Okay, cool. I did so mine. Okay, little thing. All right, so distributive properties. So I want you guys to tell me if anybody's taught you this way. If you have 2 times 3 plus 4, okay? They claim that that's the same thing as 2 times 3 plus 2 times 4. Okay? Because they say you distribute this 2 to everything inside the parentheses. But let's think about it for a minute. Just, like, why do we say that that's true? Well, if I have 3 plus 4, and I do that 2 times, right? Because we even say it out loud, 2 times. We're doing it 2 times, right? So we're going to do that twice. Okay? Is that the same as me doing twice 3? And twice 4? Do I have the same number of boxes? So do you see how that works? It's kind of tricky, right? So what we just tell you is we say you're going to distribute this multiplication over the addition. Okay? That's called the distributive property. But I'm pretty passionate about the fact that this is distributive property of multiplication over addition. Okay? People would just say it's a distributive property all day long. But I want you to understand that it only works when you have multiplication distributing over addition. Okay, that's really important because sometimes students will try to distribute stuff and it's multiplication over multiplication. It doesn't work that way. Okay, it's the distributive property of multiplication over addition. Okay, so there you have it. Now, it could be multiplication over subtraction, right? That's okay. But don't do it over division or over, okay. So here they have an example, which I kind of just did an example. All right, then the next property is the additive inverse. So in other words, what number do I add? Here I'm going to do your favorite back in the back, the fill in the blank. What number do I add to negative 2 to get 0? Negative 2 plus what? 2. Very good. Okay, so we add, so that's the additive inverse because you take the opposite sign of it, you add them together, and you're going to get 0, which is the identity, right, for addition. That's called the additive inverse. The multiplicative inverse, what am I going to multiply by 6 to give me 1? One sixth. So here's 6 times 1/6 equals 1. So that's like 6. 6 divided by 1 is just 6, right? So 6 divided by 1 times 1/6. When I multiply fractions, then I multiply the tops divided by the bottoms. So I just get 6 divided by 6, which is just 1. Okay? All right. I'm wrestling, so I must be fine. Okay, thank you, everybody. Have a good day. It's on paper.
Oh, do you, other days? teach Monday and Wednesday at 1 o'clock. And yes. Yeah, you can always, because there's always high progress at the end of the semester, so it always counts. Doesn't matter when you do it. If you can't open it though, let me know and I'll make sure you can open it.
I might be able to make Thursday. I have a job
Oh.
3:20.
Okay. Good for you.
Just let me
Good
know.
luck.
It's on US 1, so it's not far. It'll take about 20 minutes, so I probably won't be late, but just in case I am.
Okay. Okay, thank you for letting me know.
The homework assignments, they're like automatically transferring over into campus.
Yeah, I noticed that. I looked at that and I did change something that I was hoping would make it, but it would definitely transfer on the second.
Okay, because the first one I got the homework on the diagnostics and I just noticed it. I haven't worked on the other one yet to see if it would transfer over.
Yeah, I need to look at that, but there are two options on my side. I can have it report it when you submit it, but that kind of freaks students out too, because then they're like, oh, but I only got a 50, but I wasn't done.
Yeah.
So what I'm having it do is close out on the second, because I have to have them all close out at the same time. So
Okay.
there's no request coming in.
Okay. Thank you.
Okay, you're welcome. Oh, okay. Okay, how was it? Good?
Yes,
Okay.
no problem at all, yeah.
Okay, okay.
I'll
Then
see you
sorry
next-
I can't.
Oh, no problem at all. I'll see you next Thursday.
All right, thanks.
Monday on Wednesday we teach in the same class.
No, no, I teach in A 103. Yes.
Year 0.
Yeah, the A building. You know what that is? I'm not the professor, I'm just running late.
I'll ask you next time I'm here.
Okay.
I'll still be in class too.
I mean, I can go to my office, it looks like there's a class coming. So, but I think you've got it anyway, so we can chat next time. Does your teacher use the board, the first day class? Oh, it's the first day. Luckily, they're late. Or not early, anyway. I'll pass you up. Oh. Yeah, she was on this. Okay. Oh, that's Tuesday. Today's Tuesday. It's 8 a.m.
I said it's Tuesday, but I was thinking it's 8 a.m.
So you guys are probably fine. Shut this call down because they don't know. Oh, I'm not going to get anything out of it. Again, there's medical confusion. Do you want to come to my office and Oh, you're really on the Barbara? I do think. Is that your name? No, that's my name. Oh, that's yours. No, but what is your name? Okay, I'm just thinking of the Oh, it's 9:42. Oh, okay. Okay, so I guess maybe you're going to be, maybe not too late. Just your thing. Okay, sorry. Thank you. No problem.
I was checking my updates, seeing if there were any changes, but didn't go through yet.
Oh.
Thank you.
Okay, you're welcome.